Okay, so next is example 5. So we have lawn. So sorry. So the function is we have the ln of x plus y. Okay, so is there any restriction? Yes, which means that the value in the bracket here should be always positive, not include 0. Okay, so domain is the set of xy. Xy are real and the condition is x plus y should be positive, okay, not 0. Okay. Okay, now look at the range. Range is the value of z. Z is real. Is there any condition? Okay, ln. So the property of ln, if you from the previous slide, I already asked you to check the value of ln if you put any value here. So if you put the value ln of 0 point something, which is smaller than 1, you will get negative value. Okay, I mean the z is negative, but if you put 1 ln 1, you get 0. So you can say that the z value can be negative, can be 0, and also can be positive. You put, let's say 10, so ln 10 you will get more than you will get positive number. So you can say that for this particular condition, x plus y always positive, so your value of z is always can be any number, so there is no restriction, so you can just close it. So that is the range. So now the sketching of the domain. On why explain. So look at your description of your domain. Okay, so how can you say about the you must have the curve, right? Because you have the equation here. Okay, so here take up your condition. So for the sake of sketching, you put the equal sign and you have the line of y equal to negative x. So you have this one. Okay, and then about the equality. So x plus y equal to 0. So y is greater than minus x. So now, because your curve here is open curve, and you have the sign here is greater than, meaning that your shaded area should be above the line, above somewhere here. But how about the line itself? You have to provide the solid or the dash, and because of there is no equal sign for the inequality here, so meaning that there is, you have to put the dash line. Okay, so you put the dash line, and then the shade area, you can see that I can choose any point. Oh, sorry. So because we have equality here, so the shaded area is above the line. So above the line, somewhere here, over here. So you can see that whatever point, any point that you choose in the shaded area, the value of z here exists. But if you choose point down here, also you choose the point along the line, and the value of z does not exist. Okay, so that is the way how can you determine, how can you relate the sketching of the domain with the description here. Okay, so now okay, if we have a physical class, so I will ask you to provide this example. Okay, so this one is a question which I'm taking from the test 1 on 2005-2006. Okay, this one from the test 1 question. So I would say that this is exam-like question. Okay, so the question is determine the domain and the range of the function given and then sketch the domain. So in order to answer that, so now the function is a bit more complicated, I suppose. So you have 4 minus and you have the square root function. And inside the square root you have 9 minus x squared plus y squared. Okay, the first question. Is there any, okay, about the domain. Is there any condition? For the domain? Yes, of course, because we have the square root function here. But 4, there is no constraint. 4 is 4. So the constraint is coming from the expression inside the square root. So the condition is from 9 minus x squared plus y squared, then should be greater than equal to 0. Okay, so now your domain is the set of xy. Xy are real, and the condition is whatever xy that you choose, you have to make sure that the value of them should be always positive and also can be 0. Okay, someone will ask, maybe they will might wonder whether can they instead of put this equation, whether they can use other way of this equation. I mean, actually you can rearrange. So you have 9 minus x squared plus y squared greater than equal to 0, and when you rearrange this expression, and you will get x squared plus y squared smaller than. Can you, or can we, instead of write down this way, can we write down the condition in this way? Of course you can. Okay, because this one is actually from this. So you can give me this or you can give me this. Okay, both are correct. So that is the domain. Okay, now the range. The range is the value of z real. Is there any constraint? Okay, here you have to be careful because of you have the square root, and inside the square root there is a single constant 9. Okay, and also outside the square root there is a single constant value, so don't be trapped. So normally if you have this form where there is a constant value, just a single constant value standalone, so normally there is a condition of the value of z. Maybe it can give you the highest value of z or the smallest value of z. Okay, so now we want to check. So this is a bit confusing, so you have to make sure you understand enough. Okay, so here it is a bit complicated for me. This is a bit complicated for you. It's okay. So now back to the, okay, because now we are talking about the z, so you have to take into account all the term in the function. Previously, about the domain, we only focus on the restriction of the x and y. Okay, this is a bit confusing, I know. Meaning that for domain, you have to just focus on x and y. Here we don't bother about the 4 because 4 is nothing to do with the value of x squared and y squared. So the x squared and y squared, the x and y are coming from this group of expression. That's why we only check the condition. I mean, we only look at the square root function. Okay, but for the range, you have to consider the whole term, the whole expression. Now you want to investigate what is the value of z. Is that can be negative? Is that z can be positive? Or is that z can have a maximum or minimum value? Okay, here look at you look one by one. Now you can see this value. I mean, instead of the I would say there are three terms here. 4, you have 9, and you have this group of expression. You got 3, but 4 and 9, they are fixed, right? But the value of z can be changed by the value of x and y. So that's why we focus on this first. Okay, so now you ask yourself, so the value here is always positive, right? For any x and y. Yes, they are always positive. Since they are positive, so what is the smallest value then? It should be 0, right? For any x and y that you put. So there is possibility that you will get 0, and you get 1. What else? Get 8, get 9, get 100, and so on. Okay? Because of this value is always positive. Okay, now based on the value that you have here. So now look at one by one. So for the 0, so 9 minus 0, and then keep going. 9 minus 1, 9 minus 8, 9 minus 9, 9 minus 100. Okay, I'm just choosing this one. Actually, you have infinitely many numbers here, but we just want to see the pattern. Okay, so this one, this one, this one. So this will give you square root 9. They will give you square root 8. This will give you square root 1. This will give you 0, and this will give you does not exist. So if you increase the value here, so then you always get does not exist value. Okay, so here you can see that 3, and you can have 0, you can have 1, and you can have some value here. Okay, so you will say that your possible value when it is 0, so you got 3. So for any value that you put, the possible answer in this bracket only 0 to this one is actually the whole result, right? So meaning that for this value, these possible values, so your result in the bracket in red here is only between 0 and 3. Okay, so the value here is let's say I put star, is only between 0 and 3. Okay, so now because you have 4 there, okay, so based on your inner result, or the result in the bracket here, so you can have 4 minus 0, you can have 4 minus 1, 2, 3, so 4 minus 2, 4 minus 3, so you have 4, you have 3, you have 2, you have 1. So this is your z, right? So this is all your z. Then you can conclude that your z is only between 1 to 4. Okay, your z, your output value. Okay, so you have to be careful. Analyze one by one. Okay, first look at the x and y that you choose as a domain. So you said that you can choose any value, right? So you put any value. So the smallest one is 0. You will never get negative, because this is x squared plus y squared. And then we are trying to list down the possible values. So I put the smallest. So when I put the smallest, so I will get 3. So 3 here is the value in the bracket as a whole, the value of the square root, right? And then when I keep increasing the value of the x squared plus the square, and then after some times you will see that if you put the very large number, I mean the value greater than 9, so your value for the square root does not exist. So we don't want that. We only want the value to be exist. So that's why we can say that the possible value that we can have for the square root is always between 0 and 3. So 0 and 3. But then don't forget, you have 4 here. 4 minus whatever value from 0 to 3. So we try to list down 0 to 3. Okay, I use the whole number here. So 0, 1, 2, 3. So 4 minus 0, I got 4. 4 minus 1, I got 3. 4 minus 2, I got 2. 4 minus 2, I got 1. So this is only the value of z that can we have. So we have the interval z is between 1 to 4. Okay, so that is your range. So now, from that analysis, so we can say that z is only lying between 1 to 4. Okay, so that is the answer for this example. Okay, so sketching of the domain. We have been finished yet sketching of the domain. So by using the description of the domain here. So now we take out the condition, this one, or we have this, right? So our sketching based on that inequality. Okay, so when we draw the in order for us to know what is the curve that we should draw for the domain, so basically it should be from this equality expression. So for the sake of sketching, we can have just ignore the inequality for a while. X squared plus y squared equal to 9. Then we have a circle centered at the origin with radius 3. Okay, now that is our sketching. But then you have to shade the area, okay, in order for you to fulfill the condition. So the condition here says that because your curve is a closed loop, closed curve, meaning that here you have the equal. So equal means that you have to provide the solid line. There is equal sign here. And you have less than and equal to, meaning that your shaded area should be inside. Okay, so inside the circle with radius 3. So what can you say about the domain, the description of the domain and your sketching here? So meaning that the way you want to explain this is actually from this graph. You see that I can choose any xy, but only inside the circle. But if I choose outside the circle, so the value of the function does not exist. Okay, you can check. You can put any value. For example, because you know here is 3, so you can choose 3, 0. X equal to 3, y equal to 0. And when you substitute into the function here, and you will definitely get the value. However, if you choose the point outside, for example, you choose 4, 4, 0. 4, 0 is lying over here, I think. Yeah, because 4 is greater than 3, right? When you put 4, 0, x equal to 4, y equal to 0, and I'm very sure that the value of your z does not exist. That is simple, right? Okay, so this one will be quite hard for you to understand. This is very mathematics, right? Then you transform this into the graph and easy for you to explain to other people. Okay, so that's for the example where I'm taking from the question from past test. All right.